Hi, my name is Mark Hardy. This is the project implementation phase of CS6133. This is an Avenet Lx9 microboard. It's on board is a Spartan 6 processor, and let's see, it's connected via this ISS USB connection to my computer. I'm going to real quickly run the demonstration app to see the little blinky lights. I'm going to push run here on this project to stop, reset. I'm going to hit run here to see the blinky lights. That's not very exciting, but what we'll do is we'll go over here and I'm going to get onto a webinar and we're going to replay this stuff and we're going to see it a little more clearly on the webinar side. Okay, so we just took a look at the Avenet board and that USB ISS connector, and so now we're going to talk about where the software comes from, the core software implementation. So Oliver Gerard created this OpenMSP430 implementation and is downloaded from OpenCores. So basically it comes with some tools. These TCL files that let you talk directly to the cores, but more importantly, it comes with an FPGA implementation for the Lx9 microboard that lets you get started right away. It has some synthesis files on the Xilinx and some bit streams, and it's got the RTL files with all the Verilog implementation information to actually recompile the entire core. So also in this set was inside the bitstream was this README file that has a picture of this USS ISB. So this is how you can communicate onto the core that's running on the Xilinx Spartan 6 through an I2C out to a USB ISS adapter that can talk to these applications on your PC. So that's what we're going to do. Let you compile software down to an ELF file and download it directly using these tools right onto one or both of the cores. He's at a 2-core implementation. So we're going to see some of that going on. Okay, so now we're going to review the implementation. Single core, show the changes in the files and talk about the serial port implementation, and look at the 3 requested reports. So those files that were in Oliver's system were basically implemented, open up and eat into ISC. This is a Xilinx tool for managing these files. So basically they were dragged in here and Xilinx figured out where they belonged, and we identified this OpenMSP FPGA Verilog file as the primary file. And everything kind of fell in here. You can see there was an OpenMSP 0, this first instance, and each one has a GPIO, a timer, a UART, and all the RAM and all the different pieces associated with it. In the work I've done here, well, there's a UCF file that was also here, and this basically maps all of the output pins to some internal identifiers. So for this example right here, it shows L6 pin mapped to LED2 that's out on the board, and that was all supplied. In this file here, OpenMSP FPGA-V, this has the mapping between, this basically maps where the internal pins are, the internal identifiers to how the software can interact with it. And I've had to make a few changes to here to this file for my purposes. When I removed one of the cores, I mapped the additional LEDs to internal pins so I could talk to those. I added some additional I/O ports so I could talk to the J5 header, and then additionally I changed the UART pin, the transmit pin, to an internal I/O port as well, so I could output to port 1 and that would basically toggle the TX pin. So that could talk to the USB on the port, and the serial port on the port that go out the USB port, and I could run that through the cable and capture that on the PC. So that was, I think, the essence of the changes. There might be a few other changes to map these through the software, but that's basically the changes I had to make. So I recompile that in the software, and then you generate a programming file, and the programming file is a bit file, and that's loaded onto the board using the Impact software. Let me turn this off. Alright, so the Impact software is used to, when that fires up, to load the software onto the board. I won't do this right now because it loads the software onto the board, and you actually saw it running earlier. This is kind of a buggy software from Xilinx anyhow. We're going to get on to the more fun stuff. Let's see. So, alright, so so that was the implementation. It has single core, and oh yeah, there's 3 requested reports, and I'll be delivering those reports, but that's going to be the synthesis report and the map report and the place and route report. I think those are the 3 reports that were requested. So I'll be supplying those separately. So now we're going to look at the MSP software that actually runs on the implemented core. So I wrote this program here, main C, but it's in test UART. And so basically it does some setup. We saw 4 blinky lights at the very start, flashed all the LEDs, and then it's going to output to a system reset, and then the requested CS6133 Spring 2013. And then it does some more interesting stuff. We are going to do a FIR test, which was one of the tests that were downloaded from the TI site. I run it 100 times, and I started a timer that captures, it's pretty much a real clock timer, but also captures clock cycles, and we'll do some outputs of that. So we'll see that on the output, and then I just run an elapsed timer. I pause for a while and then show the elapsed time on a real-time clock. So that's implemented in a interrupt. So let's see. So that's the software. So what happens to the software? So we want to see compile software. We'll also make a change to the software. We'll save it. Basically, to compile it, we just have a make file. It's not that complicated. And now we're going to use our cool little tools to talk to the board. You set up a COM port. These are the tools that came with that TCL mini debugger file, and you set it up for I2C, and then you connect with the board, and then I can load this test serial ELF file that I just compiled right down onto the board. And so the file is loaded. It only took a couple of seconds. I can run it, and when I run it, I can bring up I have a terminal emulator that's connected there, so I'll run that. It'll kick off. We're showing the CS6133. Starts the timer, does a 100 FIR test. It took 2.6 seconds. Let's stop the program. It took 2.6 seconds, about 9 million clock cycles to execute the entire thing. And then if I let it run more, it just continues to run every 2 seconds. It pauses and then shows the real-time clock. Not very exciting, but anyhow, it's exciting to me because we got to be able to talk to all of this. Let's see what else we needed to talk about today. So we compiled the software, we downloaded the software to the board, reviewed the serial output, and I think that's everything. So if you have any questions, please send me a note. This is Mark Hardy. You can reach me at hardym8 hardym@saic.com. Thanks.